You see them everywhere. For one thing, your heartbeat. That's a periodic oscillation. At least I hope that for most of you it is periodic. Your breathing is some kind of a periodic motion. The blinking of your eyes, your daily routines and your habits, your eating, your sleeping, taking a shower, your classes, and occasionally doing some work, all those are periodic actions. When you drink, I drink some orange juice. Now notice as I try to move the liquid down into my stomach that it's not a steady stream, but it's a periodic motion. Look at my throat. In fact, even if I don't want to swallow the liquid, but simply have a bottle with liquid and I turn it over, then we all know that the water doesn't come out like a steady stream, but it goes clock, 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 clock. That's some kind of a periodic motion. I have here a toy which I use to entertain my dinner guests, particularly physicists. It's interesting. And there's liquid here, and the idea is to get the liquid there. And then the problem is, how can you do that in the fastest possible way? Well, if you turn it over, you'll see that phenomenon that I just mentioned, which is that clock, clock, clock. It's not a steady stream. It's almost pathetic, the way that it runs from one side to the other. And it will take minutes before it's there. But it can be done in 17 seconds. And during the 5-minute intermission that we have, you may give that a try. And I hope you won't break it, and see whether any of you can think of a way that you can transfer the liquid in 17 seconds. You have breakfast in the morning, and you casually put your breakfast plate on the table. What do you hear? Some kind of a periodic motion. And two things can happen to this plate. It can move azimuthally. I call this azimuthally because I'm an astronomer. But it can also wobble. In fact, something can wobble without moving azimuthally, and something can move azimuthally without wobbling. In this case, it does both. One of the most remarkable things I just mentioned to you is that the period of the oscillations is independent of the mass of the object. That would mean if I join the bob and I swing down with the bob, that you should get that same period. Or should you not? I'm asking you a question before we do this awful experiment. Would the period come out to be the same or not? Some of you think it's the same. Have you thought about it, that I'm a little bit taller than this object, and that therefore maybe effectively the length of the string has become a little less? If I sit up like this, and if the length of the string is a little less, the period would be a little shorter. Yeah? Be prepared for that. On the other hand, I'm also well, I'm not quite prepared for it. I will try to hold my body as horizontal as I possibly can in order to be at the same level as the bob. I will start when I come to a halt here. There we go. Now, you count. This hurts. Ah. I want to hear you loud. Oh. Oh, thank you. Oh. 10T with Walter Lewin. 45.6 plus or minus 0.1 seconds. Physics works, I'm telling you. All right, so I think this was convincing, at least for the fresh.